residential construction, several plumbing systems are commonly used. Firstly, PEX, which stands for cross-linked polyethylene, is a flexible, durable, and corrosion-resistant tubing. It is becoming increasingly common due to its ease of installation and low cost compared to copper. Secondly, copper is a traditional choice that is still valued for its durability and longevity. However, its higher cost and labor-intensive installation are making it less common. Thirdly, CPVC, which stands for chlorinated polyvinyl chloride, is similar to PVC but more resistant to high temperatures and is used for hot water distribution. Fourthly, PVC, which stands for polyvinyl chloride, is inexpensive and corrosion-resistant, and commonly used for drain lines and cold water supply. Fifthly, a Manabloc, or manifold plumbing system, uses a centralized manifold to distribute water to multiple fixtures, reducing the need for extensive piping. Lastly, tankless water heaters are energy-efficient water heaters that heat water on demand, eliminating standby losses. Some plumbers prefer PEX for its flexibility and ease of installation, especially in tight spaces. Other plumbers use both copper and PEX, depending on the specific application, using copper for higher-end homes or areas with extreme temperatures, and PEX for cost-effectiveness and simplicity. Some adopt a mixed approach, using copper for main supply lines and PEX for branch lines. Manabloc systems are recommended for larger homes to reduce water pressure fluctuations and improve efficiency. Local building codes may dictate which plumbing materials are allowed. PEX is generally cheaper than copper, making it a more attractive option for budget-conscious projects. PEX can be installed more quickly and easily compared to copper, saving on labor costs. Copper has a longer lifespan than PEX, but PEX is less prone to corrosion and leaks. When selecting a plumbing system, it is essential to consider various factors. These include material costs, which can significantly impact the overall project budget. Labor costs are another crucial aspect, as some materials require more specialized skills and time to install, driving up expenses. Durability and longevity are paramount to ensure the system's long-term performance and minimize the need for frequent repairs or replacements. Compliance with local building codes is non-negotiable, as these regulations are in place to ensure safety and proper functionality. Water quality is also an important consideration, as certain materials may be more susceptible to corrosion or leaching, potentially affecting the purity of the water supply. Flow rate and pressure should be carefully evaluated to ensure adequate water delivery throughout the building, especially during peak demand periods. The complexity of the building layout can influence the choice of plumbing system, as some systems are better suited for intricate designs or tight spaces. Maintenance requirements should be considered, as some systems may require more frequent inspections or repairs than others. Noise levels can vary between different plumbing systems, and minimizing noise pollution is often a desirable goal, especially in residential settings. Environmental impact is an increasingly important factor, with some materials being more sustainable or recyclable than others. Considering these factors will help ensure the selection of a plumbing system that meets the specific needs of the project and provides reliable and efficient water distribution for years to come. Diving deeper into the specifics of each plumbing material, let's first explore copper. Copper pipes have been a staple in plumbing systems for decades, renowned for their exceptional durability and resistance to corrosion. Copper's inherent properties make it an ideal choice for transporting potable water, as it doesn't leach harmful chemicals into the water supply. Its high thermal conductivity also makes it suitable for hot water lines, ensuring efficient heat transfer. However, copper's high cost compared to alternative materials has led to a decline in its popularity in recent years. The labor-intensive installation process, which involves soldering or using compression fittings, also adds to the overall expense. Furthermore, copper pipes are susceptible to theft in some areas due to their scrap value. Next, let's examine PEX, a cross-linked polyethylene material that has revolutionized the plumbing industry. PEX pipes offer numerous advantages over traditional materials like copper and PVC. Their flexibility allows for easier installation, especially in tight spaces or around obstacles. PEX resistance to corrosion and freezing also makes it a durable choice for various climates. The push-fit fittings used with PEX pipes simplify the installation process, reducing labor costs and the risk of leaks. However, PEX pipes are not suitable for outdoor use, as they are susceptible to ultraviolet degradation. Their lower temperature resistance compared to copper also limits their use in high-temperature applications. PVC pipes, or polyvinyl chloride pipes, are a cost-effective option for drain, waste, and vent systems. PVC resistance to corrosion and chemical degradation makes it suitable for transporting wastewater and other non-potable fluids. Its lightweight nature simplifies installation, reducing labor costs. However, PVC pipes are not suitable for hot water distribution, as they can soften and deform at high temperatures. Their rigidity also limits their use in complex plumbing layouts. CPVC pipes, or chlorinated polyvinyl chloride pipes, offer improved temperature resistance compared to PVC, making them suitable for hot water distribution. CPVC's chemical resistance and durability make it a reliable choice for both residential and commercial plumbing systems. However, CPVC pipes are more expensive than PVC and require specialized fittings and installation techniques. Manabloc systems offer a centralized approach to plumbing distribution, simplifying the layout and improving water pressure balance. A Manabloc manifold acts as a central hub, distributing water to individual fixtures through dedicated PEX lines. This design minimizes pressure drops and ensures consistent water flow throughout the building. Manabloc systems also allow for individual fixture shut-off, simplifying maintenance and repairs. However, Manabloc systems require careful planning and installation to ensure proper functionality. Their higher initial cost may also be a deterrent for some homeowners. Tankless water heaters, also known as on-demand water heaters, provide hot water only when needed, eliminating standby heat losses and saving energy. Tankless water heaters are more energy efficient than traditional tank-style water heaters, reducing energy bills and greenhouse gas emissions. Their compact size also saves space, making them ideal for smaller homes or apartments. However, tankless water heaters have a higher initial cost than tank-style water heaters. They may also require a larger gas line or electrical service to meet their high power demands. When considering the installation of plumbing systems, several factors must be taken into account to ensure optimal performance and longevity. Firstly, proper pipe sizing is essential to maintain adequate water pressure and flow rates throughout the building. Undersized pipes can lead to pressure drops and reduce flow, while oversized pipes can increase costs and waste water. Secondly, adequate pipe support is necessary to prevent sagging, bending, or breaking. Pipe support should be spaced according to the manufacturer's recommendations and securely fastened to the building structure. Thirdly, proper insulation is crucial to prevent heat loss in hot water lines and condensation in cold water lines. Pipe insulation reduces energy consumption and prevents damage to building materials. Fourthly, backflow prevention devices are required to prevent contaminated water from flowing back into the potable water supply. Backflow preventers should be installed according to local plumbing codes and regularly inspected to ensure proper operation. Fifthly, water hammer arresters are used to absorb the shock of sudden valve closures, preventing damage to pipes and fixtures. Water hammer arresters should be installed near fixtures that are prone to water hammer, such as washing machines and dishwashers. Sixthly, proper venting is essential to prevent sewer gases from entering the building and to ensure proper drainage. Vent pipes should be properly sized and connected to the building's vent system. Seventhly, regular maintenance is crucial to ensure the long-term performance of plumbing systems. This includes inspecting pipes for leaks, cleaning drains to prevent clogs, and testing backflow preventers to ensure proper operation. Eighthly, water conservation measures can significantly reduce water consumption and lower water bills. These measures include installing low-flow fixtures, repairing leaks promptly, and using water-efficient appliances. Lastly, compliance with local plumbing codes is essential to ensure the safety and proper functionality of plumbing systems. Plumbing codes vary by jurisdiction and should be followed carefully during installation and maintenance. By considering these factors, homeowners and plumbers can ensure that plumbing systems are installed and maintained properly, providing reliable and efficient water distribution for years to come. Furthermore, understanding the nuances of plumbing codes is paramount for ensuring safety and compliance. Plumbing codes are a set of regulations that govern the design, installation, and maintenance of plumbing systems. These codes are designed to protect public health and safety by ensuring that plumbing systems are installed and operated in a safe and efficient manner. Plumbing codes vary by jurisdiction and are typically based on model codes developed by organizations such as the International Code Council (IC) and the International Association of Plumbing and Mechanical Officials (IAPMO). Some key aspects covered by plumbing codes include, firstly, materials, specifying the types of materials that are allowed for use in plumbing systems. Secondly, pipe sizing, dictating the appropriate pipe sizes for various applications. Thirdly, fixture requirements, outlining the types of fixtures that are allowed and how they should be installed. Fourthly, drainage systems, regulating the design and installation of drainage systems to prevent clogs and sewer backups. Fifthly, venting systems, ensuring proper venting of plumbing systems to prevent sewer gases from entering the building. Sixthly, backflow prevention, requiring the installation of backflow preventers to protect the potable water supply. Seventhly, water conservation, promoting water-efficient fixtures and practices. Lastly, inspections, mandating inspections of plumbing systems to ensure compliance with codes. Compliance with plumbing codes is essential for ensuring the safety and proper functionality of plumbing systems. Failure to comply with codes can result in fines, delays in construction, and potentially dangerous conditions. Plumbers and homeowners should be familiar with the plumbing codes in their jurisdiction and ensure that all plumbing work is performed in accordance with these codes. To delve deeper into the world of water conservation, it is essential to explore various strategies and technologies aimed at reducing water consumption in both residential and commercial settings. Water conservation not only helps to lower water bills but also contributes to environmental sustainability by preserving precious water resources. Several effective water conservation measures can be implemented to minimize water waste. Firstly, low-flow fixtures. Replacing traditional fixtures with low-flow toilets, shower heads, and faucets can significantly reduce water consumption without sacrificing performance. Secondly, leak detection and repair. Promptly identifying and repairing leaks in plumbing systems can prevent significant water waste. Even small leaks can add up over time, wasting hundreds or even thousands of gallons of water. Thirdly, water-efficient appliances. Using water-efficient appliances such as washing machines and dishwashers can reduce water consumption. Look for appliances with the Energy Star label, which indicates that they meet strict water efficiency standards. Fourthly, rainwater harvesting. Collecting rainwater and using it for irrigation or other non-potable purposes can reduce reliance on municipal water supplies. Rainwater harvesting systems can range from simple rain barrels to more complex systems with storage tanks and filtration. Fifthly, greywater recycling. Reusing greywater, which is wastewater from showers, sinks, and laundry, for irrigation or toilet flushing can significantly reduce water consumption. Greywater recycling systems require proper filtration and disinfection to ensure that the water is safe for reuse. Sixthly, xeriscaping. Designing landscapes that require minimal irrigation can reduce water consumption. Xeriscaping involves using drought-tolerant plants, mulch, and other water-wise landscaping techniques. Seventhly, education and awareness. Educating homeowners and building occupants about water conservation practices can promote responsible water use. Simple measures such as turning off the tap while brushing teeth or taking shorter showers can make a big difference. Lastly, smart irrigation systems. Using smart irrigation systems that automatically adjust watering schedules based on weather conditions and soil moisture levels can reduce water waste. These systems use sensors and controllers to optimize watering schedules, ensuring that plants receive the right amount of water. By implementing these water conservation measures, homeowners and businesses can significantly reduce their water consumption and contribute to a more sustainable future. Furthermore, it is important to address some common plumbing problems that homeowners may encounter and provide guidance on how to resolve them. Plumbing problems can range from minor inconveniences to major emergencies, and knowing how to address them can save time, money, and potential damage to property. Some common plumbing problems and their solutions include: firstly, leaky faucets, often caused by worn-out washers or O-rings. Replacing these parts can usually resolve the leak. Secondly, clogged drains, typically caused by hair, grease, or other debris. Using a plunger or drain snake can often clear the clog. In more severe cases, a plumber may be needed to use a motorized drain cleaner. Thirdly, running toilets, usually caused by a faulty flapper valve or fill valve. Replacing these parts can usually stop the toilet from running. Fourthly, low water pressure can be caused by mineral buildup in pipes or a malfunctioning pressure regulator. Cleaning or replacing the affected components can restore water pressure. Fifthly, burst pipes, often caused by freezing temperatures. Shutting off the water supply and calling a plumber immediately is crucial to prevent further damage. Sixthly, sewer backups, typically caused by tree roots or other obstructions in the sewer line. A plumber may need to use a sewer snake or hydrojetter to clear the blockage. Seventhly, water heater problems can range from no hot water to leaks. Troubleshooting the water heater and replacing faulty components or calling a plumber is necessary. Lastly, some pump failure, often caused by a power outage or a malfunctioning pump. Ensuring a backup power source and replacing the pump if needed can prevent basement flooding. When dealing with plumbing problems, it is important to prioritize safety. Always turn off the water supply before attempting any repairs to prevent flooding. If you are not comfortable performing the repairs yourself, it is best to call a licensed plumber to avoid further damage or injury. Regular maintenance, such as cleaning drains and inspecting plumbing fixtures, can help prevent many common plumbing problems. By addressing plumbing problems promptly and effectively, homeowners can maintain the integrity of their plumbing systems and prevent costly repairs down the road. Lastly, let us consider the future trends in plumbing technology and materials, which are constantly evolving to meet the demands of sustainability, efficiency, and convenience. As technology advances and environmental concerns grow, the plumbing industry is adapting to incorporate new innovations that improve performance and reduce environmental impact. Some emerging trends in plumbing technology and materials include: firstly, smart plumbing systems, utilizing sensors, controllers, and data analytics to optimize water usage, detect leaks, and monitor plumbing system performance. These systems can provide real-time insights into water consumption patterns and alert homeowners to potential problems. Secondly, waterless urinals, eliminating the need for water to flush urinals, saving significant amounts of water in commercial buildings. These urinals use specially designed cartridges or traps to contain odors and prevent sewer gases from escaping. Thirdly, point-of-use water heaters, providing hot water only where and when it is needed, reducing energy waste and improving efficiency. These water heaters are ideal for applications such as hand-washing stations or remote fixtures. Fourthly, antimicrobial plumbing materials, incorporating antimicrobial agents into plumbing materials to inhibit the growth of bacteria and other microorganisms. These materials can help to improve water quality and reduce the risk of infections. Fifthly, self-healing pipes, utilizing materials that can automatically repair small cracks or leaks, extending the lifespan of plumbing systems and reducing maintenance costs. These materials contain encapsulated polymers that are released when a crack occurs, sealing the breach. Sixthly, modular plumbing systems, using prefabricated plumbing components that can be easily assembled on site, reducing installation time and labor costs. These systems are ideal for new construction or renovation projects. Seventhly, sustainable plumbing materials, utilizing materials that are environmentally friendly, such as recycled plastics, bamboo, or bio-based polymers. These materials reduce the environmental impact of plumbing systems and promote sustainability. Lastly, 3D printed plumbing components, allowing for the creation of custom plumbing components on demand, reducing lead times and minimizing waste. This technology can be used to create complex shapes or replace obsolete parts. As these and other innovative technologies and materials continue to develop, the plumbing industry will become more efficient, sustainable, and resilient. By embracing these advancements, plumbers and homeowners can create plumbing systems that are not only reliable and functional but also environmentally responsible.